Thank you. About a year ago, I was asked to go look at a installation where a robot, a room service robot in a hotel, had been connected to a 5-car group of elevators, and was absolutely fascinated by it. And I found, like everything else, that when you start looking into things, everything is a lot more complicated than you ever thought it was, and that was the case with robots. So there's many types of robots, and there's military robots. There's milking robots. There's household robots that mow your lawn and clean your carpets. And then there's entertainment robots that'll entertain your children. And there's what we're mostly familiar with, which are industrial robots in assembly lines. But the type of robots that we're interested in, that I was looking at, are service robots. Service robots here, this is a robot doing room service. And without lifts, service robots are limited to one single level. So you have to have lifts in order you have to integrate them with lifts in order to make them work properly. And so where are we going to see service robots deployed or employed? There's various market segments. And so one of them is hotels and hospitality. And there's a couple of uses there, several uses there. One of them is room service. So you order something and the robot delivers it to your door, and when he gets out in front of your door, he calls you on the room phone, and you go get whatever it is, and you don't have to pay a tip. So then there's housekeeping, and if you look at housekeeping carts, they tend to be very heavy, and the people that actually are doing the housekeeping tend to be kind of on the small side. So there's a lot of back injuries and that type of thing. So there's one company that's working on a cart that arrives at the place where the housekeeping person is, fully provisioned, and then it follows them as they move from room to room, and then when they've depleted all the supplies, another robot shows up, and there's no need to push this. So it's an interesting concept, and one of the things you have to consider in high labor rate countries is the cost of the minimum wage keeps going up, and so the attractiveness of robots is also going up. Another one is luggage. So there are robots that they'll take your luggage, and a human will take your luggage, put it in the robot, and then the robot will deliver it to your door. And then using your room key, it knows that it's you, and it lets you open the cart, get your luggage out, and again, no tip. Another place is meet and greet. So as you enter the hotel, the robot will meet you and give you a greeting or direct you onward to other locations. Hospitals, they're being used there for pharmacy deliveries. So if they order some medications that'll deliver it, and today they're using like pneumatic tubes, and it'll go to a nurse's station. Well, with a robot, it'll actually go to the room where the nurse can, if she has the right RFID badge, the robot will open up and she can take the drugs, or he. And then also for returning lab samples. Pneumatic tubes usually can't be used to return lab samples because of the high acceleration rates to separate like blood samples. Because one of the things they do with blood is put them in a centrifuge. So, but with the robot, you don't have the centripetal accelerations that cause the blood parts to separate. Office buildings is another interesting area where robots are being used. They're being used for package and mail delivery, and really interesting is that the world's largest package delivery company, FedEx, in their world headquarters is now beginning to use the robots to deliver all of their own internal mail, and they're using the lifts to go between floors. So it's an interesting concept. I'm sure will spread to other areas. Food delivery. So there's places where if you order in some food to your desk rather than go out to lunch, the robot will actually deliver it to you. And then in residential buildings, this is now becoming much more common in high-rise, high-end residential buildings, that package delivery. So if you order something from Amazon, the final leg will be to your door, carried by a robot. So interesting possibilities. So I went and I read an article in New York Times about a robotic installation in a place called San Gabriel, California, which is a suburb of Los Angeles. I only live about 200 kilometers from there. So, oh, I've got to go up and see this. And so I went to see it, and it's a hotel, and it's a hotel, interesting hotel in San Gabriel, California. The majority of the population are people originally from China or Chinese ancestry. And this hotel looks and feels like you're in a hotel in China. And everyone who works in there speaks Mandarin or Cantonese. And so if you look at here, this is a human that greets you when you enter the door, but this is a robot that also greets you when you enter the door. And so the first screen you see when you walk up to this robot is need directions. And you see it's in English and in Mandarin. And so you select the language that you want, which I did. And then it comes up with this, where can I take you? And it has the grand ballroom, the Santa Monica room, restrooms, lobby bar. So I picked the lobby bar. And it says, you've chosen the lobby bar, and can I take you there now? So I selected yes, and so the robot starts turning, and it shows a picture of the lobby bar, and then we follow it to the lobby bar, and it was really interesting. Now here's one of the other ones. This is the luggage robot. Now it has the same. This part here and this under part can be used for multiple uses, because this device here goes underneath the cart, lifts it up, and then put your luggages in there and takes it to your room. So this was a really interesting installation. The lifts were put in by Otis, and one of the questions I asked is, are these things riding in the lift with passengers? Oh no, this is private lifts just for them. And I'll talk about why that is in a few minutes. So there are two basic types of service robots that you're going to find where they need lift service. And so there's this high mass type. And you notice that there's a young boy that's fascinated by it, and he's being, the children really like robots. So these are high mass robots. And then there's this one here that's a very low mass robot. And so each one of these has different characteristics, different considerations that need to be addressed. And again, one of these things, the more I looked at it, how safe are these things, and are they going to run into us or cause us problems? So in looking at that, the low mass robots are typically, they have like a 50 kilogram mass, which is not a whole lot. And this particular robot has a footprint that is a 500 millimeter circle, so half a meter. And it's able to turn within itself. So it has a turning envelope of 500 millimeters. The high mass robot's a whole other story. And these can be like 600 or 700 or 800 kilos. And this is the dimension of this particular one. So you can see it's fairly large, and its turning envelope is that big. So that won't fit in most small lifts. Certainly wouldn't fit in like a 630 kilo lift with that turning radius. And you wouldn't want to be in the lift with this guy, I don't think. So there is a standard for safety for robots. It's ISO 13482. And it's robots and robotic devices, and it gives the safety requirements for what are defined as personal care robots. These personal care robots can do all kinds of things, but in this case, the type of robot that we're talking about are classified as personal care robots. And there are requirements for two types of these. One type is type 1.1, and these are defined as small and lightweight and slow and no manipulator. These are non-dimension terms, so they're kind of vague, and I think that's by design. And then so the low mass robot falls into that category. Then you have type 1.2, which says large or not lightweight, or fast, or with a manipulator. So a manipulator would be an arm that would come out and do something. So and these are Boolean expressions. So you either meet them or you don't. And so that's one with the one that was at the hotel, the Sheraton Hotel, would be the type 1.2. And so this standard, ISO standard, identifies 53 hazards that need to be addressed by risk assessment. These include being shocked by the recharging device. They include fire risks. It includes one of the big major ones is tipping over. And so that you wouldn't want this thing, particularly a high mass robot, to tip over and land on you. So so it requires the robots to achieve something called performance levels, and performance levels are established in another ISO standard, which is safety-related parts of control systems. And so they both have the same emergency stop standard. These standards are actually like mean time between failure standards, so reliability standards. But for the high mass robots, they have some of they're asking for more reliability in certain components other than the safety circuit. And you can read these. It's a very interesting thing to read when you can't sleep because it helps you to sleep. But they're interesting standards. So in trying to come up with, well, what other guidance is there for these types of devices, I looked to the ASME code. And in the ASME code, there's a type of giant dumbwaiter that's called it's a type of cart lift, and they're used in hospitals, and so they're much larger than a standard dumbwaiter. They carry 400 kilos, which is more than most dumbwaiters do, and they have these cart lifts. They have an arm so you take a cart and you set it in front of the closed dumbwaiter door. And the doors open up when the lift gets there, and this arm pulls the cart in. And then the doors close. It takes it to a destination floor. It's a call and send type system. It's similar to destination on the control system. And then when it gets the destination floor, the door opens up, and this arm pushes the robot out into the hallway. Well, initially they were pushing them out into people and crushing people. And so a standard had to be developed to address these problems. And so what the ASME code said is the maximum speed while you're pushing this cart out into the floor is 0.5 meters per second. And that seems reasonable. That's about the speed that a person in a wheelchair walks, or wheels. And then it has a maximum kinetic energy of 40 joules during the unloading. And that's, I think, through that you're addressing the crushing hazard. And so these seem like very, very reasonable guidelines. Even though they don't apply to this, it's something that should be looked into. And there probably should be a standard or a code of some type made up to address robots. And so remember, with kinetic energy, it's 1/2 the mass times the velocity squared. And so if we take a look at the low mass robots, the maximum speed is that this robot will run at is 0.76 meters per second. And that does not, and the mass is so low, kinetic energy is not an issue. So but the loading speed, I still think, should be slowed down to 0.5 meters per second, just so that you don't intimidate people when it's loading or unloading. And can you share the car with humans? And the answer to that is yes, and that's what they're doing. And so we're trying to figure out, well, how much space does this robot need? It's not the 0.21 square meters. I think you need, as at least, I don't know what you really need, but as a starting point, I'm using 0.5 meter squared for the robot space. And part of that is personal space. Now, I believe that the personal space required is directly proportional to the person's age. So the little kids will be happy being near it. When we walked out of the lift, my wife was with me, and she saw the robot, and she jumped back, but she's my age. And so I think I've seen this in other things. So the kids are going to love them. The older you are, the more you're going to be cautious of them. But it's good to know what the personal space requirement is. High mass, well, the problem there is that they also have a maximum speed of about 0.76 meters per second. But the loading speed has to be slowed down to 0.365 because of the kinetic energy requirement. And so it's a serious thing. Share the car with humans? I don't think so. And in this particular hotel, they were not sharing it. And personal space in this case is not applicable. Okay. So I wanted to look at, after I looked at this first one, we installed a serial interface on Sean Park and I at a hotel in San Jose, California, and I was concerned about, gee, what is the impact on the traffic in the hotel? Because this is an extra passenger, and since it happened to be a control system that is a proprietary control system whose algorithm is accurate in Elevate, I decided to see, well, let's run some simulations. I got the data from the hotel on the number of rooms since I was there, and this capacity and speeds, and did some analysis. So I used a traffic pattern that's available in a template available in Elevate for hotels in the morning, and that's usually the worst time in the morning. So I applied that to it. And so I got, first of all, the waiting time should be without any robot. It came out with these results, like waiting time of 36.1 seconds, and that was the average waiting time. Average transit time of 57 seconds, and then waiting time with no robots with one. I want to see, well, what if it was one additional human? What would that do? So I got the same calculations, and they're summarized in a table shortly. And then we said, okay, now what's the waiting time with one robot? Well, the robot has more personal space, so that, and he's going to load and unload more slowly, and so because of that, it's going to take the robot. It's going to have an effect on traffic, and so the transit time is also affected. And so here's the summary of these, and so if we have no robots, we have this waiting time, this transit time, time to destination. If it's one additional person, it would be these. And if it's just one robot, not one additional person, this is one robot every 5 minutes, a round trip every 5 minutes. So he goes up, delivers the breakfast, and then comes back down. And so you have 5 seconds additional waiting time, 1.2 seconds additional transit time, for a total of 6.2 seconds. So that's actually there's an impact there, and that's just one robot. And we envision there being multiple robots in a lot of applications. So the conclusions from all of this, well, the invasion is real. They're coming. They're seeing more and more every day, and more requests to hook robots up and do an interface with the lift system. They are a new class of passenger. They're not the same as a human, at least for now. Though I suspect as people get more used to them, and as the technology continues to progress, they're going to become they're not going to have so much impact on traffic. Maybe even help traffic, because they'll be delivering things where people, instead of people taking the lift themselves. Kinetic energy and speed are issues that need to be monitored, and there needs to be some standards developed at some point by someone, so that we don't end up inadvertently hurting somebody, even though they may comply with the ISO standard. That the ISO standard doesn't specifically address lifts. And then robots do represent additional traffic, and so I think that lift professionals need to understand robots, because you're going to have to deal with them, because they're everywhere. Now, why are they showing up so often now? There have been robots that rode in lifts for 20 years. But they were very expensive, and they required wiring in the floor they'd use for guiding. These new ones don't need any of that, and the price has gone down. It's just like remote monitoring or machine learning that everybody's doing. We heard on this last presentation. We could have done machine learning, and we could have done all of this 15 years ago. We couldn't have afforded it. Today we can afford it. Everything's cheap. Same is happening with robots. The price is coming down. You're going to see the prices are coming down. The sophistication is going up. They're using machine vision. They don't need any wires in the floor, and labor rates are going up in most of the world. So we need to understand this. If someone says, I'm going to build a building, I'm going to have a hotel, but I want to have robots, we need to, if we're designing a system, recommending a system, we need to take this into account and see what the impact is, and make sure that the management, the building owner knows what the impact is going to be.